Hello,
Good evening, ma'am.
good evening. Can you see my slides?
Yes, ma'am.
Okay. So, good evening. Welcome back to NPTEL PMRF tutorials on Introductory Organic Chemistry 2 by Professor Harina Chakrapani and Professor Niraja Deshaputre. Myself, Anisha Suresh, PMRF TA for this course from IIT Bombay. So, today we are going to discuss week 4 assignments for this course from previous year. So, do you have any doubt regarding week 3 assignments that we discussed last week? Hello.
Ma'am.
Do you have any doubt regarding week 3 assignments that we discussed last week?
No, ma'am.
Okay. Now, can we move to question 1?
Yeah, ma'am.
Okay. So, coming to question 1, arrange the following molecules in the order of their decreasing boiling point, and they have given acid, alcohol, and an aldehyde. That is acetic acid, ethanol, and ethanol. So they have asked us to arrange these in the order of their decreasing boiling point. So what is the factor that determines which is having the highest boiling point among these three is hydrogen bonding. In case of alcohol and carboxylic acid, there is possibility for formation of intermolecular hydrogen bonding. As we can see here, uh, this alcohol molecule as well as carboxylic acid can form hydrogen bonding, intermolecular hydrogen bonding, and because of that, this intermolecular hydrogen bonding will account for around 10 kilocalorie per mole of energy, and because of that, these alcohol and carboxylic acid will be having greater boiling point. Out of alcohol and acid will be having greater boiling point, because in case of acid it will lead to formation of dimer molecules like this. Because of that, acid require even more temperature for boiling. So is it clear? Acid is forming dimer molecules like this because of intermolecular hydrogen bonding, and because of the formation of these dimer molecules, the boiling point of acid will be greater than that of alcohol. So now, coming back to our question, out of this acid, alcohol, and aldehyde, acid will be having the greatest boiling point, then comes alcohol. These both account for the intermolecular hydrogen bonding that is taking place for the greatest boiling point in these two molecules. And in case of aldehyde, there is no possibility for formation of hydrogen bonding, and it will have the least boiling point. So the correct answer, excuse me. So, among these three, acid, alcohol, and aldehyde, the greatest boiling point will be for acid, which accounts because of the intermolecular hydrogen bonding and the formation of dimer in case of acid. And then comes alcohol because of intermolecular hydrogen bonding, and the least boiling point comes for aldehyde, where there is no possibility for formation of intermolecular hydrogen bonding. So the correct answer will be 1 greater than 2 greater than 3. Is this clear?
Yes, ma'am.
Okay. Now moving forward to question number 2. Identify the intermediate X and product Y in the following reaction sequence. They have given medial Grignard reagent. The CH3MgBr is called medial Grignard, and carbon dioxide. In presence of dry ether, it will give an intermediate X, and that upon hydrolysis will give Y and magnesium hydroxy magnesium bromide. So we have to find out what is X and what is Y. So we know that this is Grignard reagent RMgBr, and since magnesium will be positive charge, this R will be of negative charge. Then this R will undergo nucleophilic addition to this carbon dioxide carbon, and it will lead to formation of this species R double bond O minus MgBr. Is this clear? R will be having negative charge as it is adjacent to this alkali metal, this alkaline earth metal magnesium, and it can undergo nucleophilic addition to this carbon dioxide and will lead to formation of this intermediate. This is the intermediate R double bond O minus MgBr plus. So, coming to our question, they have given CH3 MgBr and carbon dioxide. So, if this CH3 will undergo nucleophilic addition to this carbon dioxide, it will lead to formation of this species CH3 double bond O minus MgBr plus. Now, that upon hydrolysis means like in presence of water and mineral acid, it can undergo this O minus can take up this proton and it will lead to formation of carboxylic acid, and this MgBr plus will take up OH minus and it will give MgOHBr, that is hydroxy magnesium bromide. Is this clear? Is the mechanism clear?
Yes, ma'am.
So the correct option will be, first we will get this intermediate CH3 C double bond O MgBr, and then it upon hydrolysis will give this acid. So this will be the correct option. Is this clear now?
Yes, ma'am.
Okay. Now coming to question number 3. Predict the final product in the given reaction. They have given benzoic acid, and in presence of AgOH and allyl bromide, it will give some product P. So they have asked us to find out what is this product P. So what is happening here? This is benzoic acid, and AgOH, it will be a nucleophile. It can undergo nucleophilic addition reaction to this carboxylic acid sender. Then a tetrahedral intermediate will form. Then upon this falling back, this hydroxyl group will eliminate and we will get this species, this C double bond O minus Ag plus species. And since this oxygen is having delta negative charge, it will undergo SN2 reaction with this allyl bromide, and it will lead to formation of this product double bond O minus, and then allyl will add on to that. It will undergo SN2 addition reaction. This species, this intermediate species will undergo SN2 addition reaction, means SN2 substitution reaction with this allyl bromide, and it will give this desired product. So out of these four, this option C is the right answer. Is the mechanism and answer clear? How it is taking place?
Yes, ma'am. Clear, ma'am.
What? I will explain once more. Here we are having benzoic acid. AgOH is a nucleophile. This lone pair of electron, this lone pair of electrons on this AgOH will undergo nucleophilic addition reaction to this electrophilic carboxylic acid sender, and this electron density, like this carbon oxygen double bond will break, and it will lead to formation of tetrahedral intermediate, like O minus OH and this kind of tetrahedral intermediate will form. Then proton transfer can take place from this to this oxygen will abstract this proton transfer can take place, and it will lead to formation of O minus O Ag. Oh, sorry. This O minus will abstract this proton, and it will lead to formation of OH and OH. Okay. Instead of this O minus will abstract this proton, and it will lead to formation of OH tetrahedral intermediate. Now when this folds, this hydroxyl group will eliminate, and it will lead to formation of this species. So here partial negative charge is there. So this negative charge will undergo SN2 substitution reaction with this allyl bromide. So first it will go and attack here. This double bond will shift here, and this Br will eliminate, leading to formation of this product. Is the mechanism clear?
Yes, ma'am. Yes.
Okay. So we will get this ester as the product. The solar symbol reactions were just addition elimination mechanism is taking place. First, nucleophilic addition will take place, leading to tetrahedral intermediate, then elimination will take place. Most of the mechanism in case of acids are just nucleophilic addition and then elimination. Now coming to question number 4. The Williamson ether synthesis is one of the several ways to synthesize ethers. What type of mechanism is involved in this? And the four options given are SN1, SN2, E1 and E2. So in case of Williamson ether synthesis, um, a deprotonated alcohol will react with alkyl halide to form uh, ethers. A deprotonated alcohol will react with alkyl halides to give ethers. So as we can see here, this is an alcohol moiety. It will in the presence of a base, this proton of this alcohol will be abstracted. Then it will lead to formation of alkoxide ion, and that alkoxide ion will undergo SN2 reaction with this alkyl halide, basic probably primary alkyl halide, and it will lead to formation of ethers. So what is the reaction that is taking place here? SN2 reaction. So according to the question, our correct option will be SN2. Alkoxide ion will be generated in the presence of a base, and that will undergo attack on SN2 attack on this alkyl halide, and it will lead to formation of ethers. That is Williamson ether synthesis. It is a name reaction. Is this clear?
Yes, ma'am.
So our correct option is SN2. Now coming to question number 5. The ether is more volatile than an alcohol having the same molecular formula. This is due to. So the options given are dipolar character of ethers, alcohols having resonance structures, intermolecular hydrogen bonding in ethers, intermolecular hydrogen bonding in alcohols. So if you are clear with option, whatever question 1 we have discussed, you will be easily able to answer this question 5. So what will be the reason why ether is more volatile than alcohol?
Because alcohol, there is no possibility to form a hydrogen bond, ma'am.
In case of either na alcohols, there will be see, in case of alcohols there will be possibility for forming hydrogen bonding. Alcohol will be having oxygen, electronegative oxygen and hydrogen atom, so it will lead to formation of hydrogen bonding. But in case of either, it will be having, instead of this hydrogen, any R group, like R group can be anything like aryl group or any alkyl group. So there will be no possibility for hydrogen bonding. If there is hydrogen bonding, it will held together these alcohol molecules. But in case of ethers, there will be no hydrogen bonding, so this molecule will be not held together, and because of that they will be more volatile. Volatile means its boiling point will be less and it will easily evaporate. Clear, right? So, alcohols are having intermolecular hydrogen bonding, and because of that, alcohols are less volatile. Ethers are not having hydrogen bonding, and that is the reason why ether is more volatile than alcohol. Is this clear? Any
Ma'am,
doubt?
once again repeat, ma'am.
Actually, as we can see here, this is alcohol. ROH is alcohol. And alcohol can form hydrogen bonding. There is electronegative oxygen atom and hydrogen atom. It can form hydrogen bonding, and hydrogen bonding accounts for 10 kilocalorie per mole of energy. And after breaking this only, like uh, after giving that much energy for breaking hydrogen bonding only, this alcohol will be able to boil. That much energy is needed for boiling alcohols. So this in case of alcohols, because of hydrogen bonding, all these alcohol molecule will be held together, and they will be less volatile. Volatile means they will be having less chance to evaporate. Alcohols will be having less chance to evaporate. But in case of either, consider either will be R O R dash. It is any group other than hydrogen, like alkyl groups or aryl groups. So here there is no possibility for formation of hydrogen bonding. So this will exist as individual molecules. There will be no such binding force that will keep these molecules together. So it can like evaporate very fastly. Like its boiling point will be less, and since they are not held together, they will be moving apart from each other, and it will be more volatile. There is no hydrogen bonding in case of ethers. So why ether is more volatile than alcohol means, in case of alcohol there is intermolecular hydrogen bonding, but in case of ethers there is no intermolecular hydrogen bonding, and because of that ethers are more volatile than alcohol. So correct option will be option 4. Is this clear?
Um,
Clear now?
Clear, ma'am.
Okay. Now we will move to question number 6. So they have asked, predict the product of the following reaction. They have given a cyclic anhydride, and in presence of ethanol in reflex condition, what is the product that will be formed? So this type of moiety is called anhydride, and anhydride on treatment with alcohol, ethanol is an alcohol, what will be the product that will be formed? So coming to mechanism, here is the anhydride and the alcohol. Then alcohol will attack on the carbonyl carbon of this anhydride. Then this carbon oxygen double bond will break. It will lead to tetrahedral intermediate. Then once it is falling back, this carbon oxygen bond will break and it will lead to formation of this intermediate, where there is a positive charge on this oxygen atom and a negative charge on this oxygen atom. Now, when there is a proton transfer from this oxygen to this oxygen, it will lead to formation of this product. Is this clear? How the mechanism is taking place?
Once again, repeat, ma'am.
So here this is the anhydride and this is the alcohol. So the lone pair of oxygen on this alcohol will attack on this pos- electropositive carbonyl carbon of this anhydride. Then this carbon oxygen double bond will break, lead to formation of O minus, and that O minus once it falls back, this carbon oxygen bond will break and it will lead to formation of this intermediate. Is this clear till this intermediate?
Yes, ma'am.
Then proton transfer can take place. Here this oxygen is having positive charge, this oxygen is having negative charge. This oxygen will abstract proton from this positively charged oxygen and it will neutralize this oxygen. That is how proton transfer is taking place here and it will lead to formation of this product. Mechanism is clear?
Clear, ma'am.
Okay. So coming back to our question, out of these four, what is the right answer? So we have seen the mechanism and from that it is clear the correct option is option 4. This is the right option. Clear, right?
Yes, ma'am.
Okay. Now we will move to question number 7. What is the major product of the given reaction? This is also a similar. This question is also having similar mechanism as that we have discussed in the previous question. Here also they have given a cyclic anhydride and they are treating it with methylamine and asking for what is the product that will be forming. What is P? So coming to mechanism of this question, similar to previous question, here instead of ethanol, we are having this methylamine and this lone pair of electrons on this methylamine will go and attack on this carbonyl carbon. Then this carbon oxygen double bond will break, leading to formation of tetrahedral intermediate. And once that tetrahedral intermediate is falling back, this carbon oxygen bond will break and it will lead to formation of this intermediate. Here this cyclic structure is opening up, leading to form this linear structure where there is a positive charge on this nitrogen atom and a negative charge on this oxygen atom. Clear, right? How it is happening? You can try.
Clear, ma'am.
You can try working out in your notebooks this mechanism. Then it will be clear. Now there will be proton transfer taking place from this nitrogen to this oxygen, leading to formation of this product. So one amide and one this anhydride is converted into an open shade amide and an carboxylic acid. So the correct option is option C. Clear, right?
Yes, ma'am.
Okay. Now coming to question number 8. What is a major product that is formed in the following reaction? They have given an epoxide and it is treated with this uh, PHS Na. Like it will be S minus and Na plus. That is, this will be a nucleophile. Nucleophile will attack on this epoxide and it will open up, leading to formation of one of these four products. So how is the opening take place and from which side it is opening, that is important here. So coming to the mechanism, here this PHS minus, it is a nucleophile. It can undergo SN2 reaction. SN2 reaction means there will be an inversion of stereochemistry. It can attack from this side or from this side. Which side which will give the major product, that we will discuss later. So once this SN2 reaction will take place, it will give either of these two products. If attack is taking place from this side, it will lead to formation of this product, and if attack is taking place from this side, it will lead to formation of this product. Is this clear how?
Yes, ma'am.
Since it is SN2 reaction, it is coming from the opposite side. This SPH group is coming from the opposite side. Now we can see which is the correct product. So we can imagine or we can redraw this molecule in this chair format. This can be drawn in this format, right? Transdecalin. It is a transdecalin kind of system, and here this oxygen atom is above, like it is coming in the axial phase, and here it is connecting this equatorial side, like it's connecting the axial and equatorial side. This epoxide is from this axial and equatorial side. So here when SPH is coming, it will be coming from the axial direction, and here when SPH is attacking, it will be coming from the equatorial side, because here oxygen is in the axial side and here this oxygen is in the equatorial side. So from here if SPH is attacking, it will come from the axial direction, and here if SPH is attacking, it will come from the equatorial direction. So this SPH is a bulky group. So bulky group should always like should be away from the axial side. Bulky group should be away from the axial side. It is clear now. So because of that this will be the major product, because here if attack is taking place, SPH group will come in the equatorial side, and since it is bulky, equatorial attack will be more favored over axial attack. So the major product will be this one. Is this clear how we
Yes, ma'am.
okay? So out of these four, the major product that will be formed is option A, this one. I hope these 8 questions are clear. Now we will move forward to question number 9. So in this question number 9, predict the major product formed in the following reaction. So they have given an allylic alcohol, and in presence of this peracid, what is the product that is formed? Whether epoxide will form in the same direction or in the opposite direction, or it will lead to formation of both, or it will not lead to formation of any of these product. So coming to the answer, actually when there is alcohol, the attack will take place from the same side, and that is because of this intermediate. where there is chance of hydrogen bonding with this alcohol, that peracid will form hydrogen bonding with alcohol, leading to formation of an intermediate similar to this, and from here epoxidation is taking place. So if alcohol is coming in the above phase, then epoxidation will also take place in the same phase. If the substrate is having alcohol, there is possibility for formation of intramolecular there is a possibility for formation of hydrogen bonding with this peracid, and then epoxidation will take place. So epoxidation will be taking place from the same side as that of the alcohol. Is this clear?
Once again, repeat, ma'am.
Here this alcohol will form hydrogen bonding with R C double bond O OH. This is the peracid, and this is the electrophilic oxygen atom, where this alkene will attack and lead to formation of epoxide. So this alcohol will form hydrogen bonding interaction. See, this is the alcohol CH2OH. It is forming hydrogen bonding with this peracid oxygen. This is the peracid. This is the peracid. So it is forming hydrogen bonding interaction with this peracid oxygen. See here also hydrogen bonding is forming, and because of that hydrogen bonding, this peracid will come from the same phase as that of this alcohol. If this alcohol is above, then peracid will also attack from the above phase, and because of that the epoxide will be coming from the above phase. Clear, right?
Yes, ma'am.
So, in our second example, we can see if there is no such alcohol, instead of alcohol, if there is acetate, so the peracid will come from the other phase. That is because here what that determines the stereochemistry is hinderness. This OAC can hinder that peracid from coming from the above phase. Here we can see epoxidation of cyclic alkenes is stereoselective, with reaction taking place on the less hindered phase. So when we are considering this case, if OAC is present above or some group is present already in one phase, the peracid will be coming from the opposite phase. It will come from the less hindered phase. This phase will be hindered by this group, so the peracid will come and attack from the less hindered phase, and that will be the major product. But here, because of this alcohol, it can form hydrogen bonding with this peracid. It will direct this peracid from the same phase as that of the alcohol. See, directed by hydrogen bonding to a hydroxyl group. That is why we are getting the product from the that epoxidation from the same phase as that of the alcohol. Clear, right?
Yes, clear, ma'am.
Okay. So our question was, out of these two, which will be the major product that will be formed in case of this reaction? So A, B, both A or B, neither A nor B, which will be the correct answer? This is the right answer, right? Option A. Because here alcohol is there, and alcohol can form hydrogen bonding with this peracid, and it will direct the peracid to attack from this above phase only. So epoxidation will take place from the above phase, and we will get this as the major product. We will get minor this product as well, but since our question is what is the major product, this will be the right answer. Is this clear?
Yes, ma'am.
If you have any doubt, you can feel free to ask, okay?
Okay, ma'am.
Hmm. Now we will move to question number 10, and it is the last question of this tutorial. What is a major product formed in the following reaction? So they have given this is the starting material. They have treated with this mercuric acetate and then followed by reduction with sodium borohydrate. What is the product that is formed? Out of these four options, what is the right answer? So from the reagents, we can see that first oxymercuration reaction is taking place and followed by reduction using sodium borohydrate. So first I will be discussing about oxymercuration reaction. So in case of oxymercuration reaction, when an alkene is there, it will undergo reaction with this mercuric acetate, lead to formation of this mercurinium ion. Then water will attack from the more substituted side. That is, Markovnikov addition of water will take place, leading to formation of this intermediate. Is it clear? First, this alkene will add on to this mercuric diacetate. It will lead to formation of this mercurinium ion. Then Markovnikov addition, that is addition of water from more substituted side. This is more substituted side. See here carbon is substituted with one hydrogen and one methyl group, and here carbon is substituted with two hydrogen. So this is the more substituted side. Water will attack on the more substituted side. It will lead to formation of this intermediate. Clear, right?
Clear, ma'am.
Yes, ma'am.
And it will lead to formation of this. Here this proton from this water will be abstracted by another water molecule, and it will lead to this product. So here this addition is anti-addition. Anti-addition means addition from the opposite side. See here SN2 kind of addition is taking place. Here water is attacking and this is opening up. So this alcohol and mercury will be coming from in different phases. Then, upon sodium borohydrate treatment, hydrate ion will go and substitute this mercuric acetate and lead to formation of alcohol. So, from alkene, we will get alcohol. That is oxymercuration reduction. This is the mechanism for oxymercuration followed by reduction. Clear, right?
Yes, ma'am.
So this was our question. So what is the major product of the following reaction? Once oxymercuration reduction take place, here there will be alcohol. Alcohol on the more substituted alcohol will form, and here there will be alkane. And since here there is ester in presence of NaBH4, this ester will also reduce into alcohol. NaBH4 reduce this ester into alcohol. So our right answer will be this one. First oxymercuration reduction will take place, and at the same time this ester will also be reduced into alcohol. Clear?
Once again, repeat, ma'am.
Uh, First oxymercuration reduction, as we have seen here, um, this this is the mechanism for oxymercuration reduction. So here as we can see, alcohol will form on the more substituted carbon. So coming back to our question, here this is the more substituted carbon. In this, this is the more substituted carbon, right? Out of these two, alcohol will form on this carbon in case of oxymercuration reduction. This alkane will convert into, see, this double bond CH2, CH2, O, double bond O, ester. So here, upon oxymercuration reduction, it will lead to formation of a tertiary alcohol like this. But they have not mentioned how many equivalents of sodium borohydrate they used. And here there is an ester in this system. So ester upon reduction, it will lead to formation of alcohol. That we have already learned in lower classes, right? Ester will convert into alcohol. So OH, and it will lead to formation of alcohol. Hydrate will add, it will lead to formation of O minus. Then once upon falling back, this bond will break and it lead to formation of alcohol. So the correct option will be this one, tertiary alcohol, and a primary alcohol will be formed upon this reduction of ester. Clear?
Yes, ma'am.
Okay. So this was the last question of this assignment. So if you have any doubt, you can feel free to ask me. Any doubts? If no doubts, thank you for listening my lecture today, and we can meet on next Tuesday from 6 to 7 p.m. Thank you.